I'm about to do something that most of you will probably find disconcerting. And in fact, the first time that I saw someone do this, I too found it disconcerting. So just as a little bit of background, so far when we've been thinking about our space axis, and we've really just been focusing on one dimension of space, we've been focusing on the x dimension or the x prime dimension, depending on whose frame of reference we are talking about. We measure that in terms of meters. And then when we thought about time, initially we said, time is fundamentally something different than space. So we had a different set of units called seconds. In fact, this goes well before the 20th century when we got special relativity. This goes all the way back to Newton, well before even that, where we said, hey, time is something different. We measure it in units of time, in seconds or minutes or hours or days, while distance, which is different than time, we measure it in meters or feet or miles or kilometers or whatever else. But as we started to get into this world of special relativity, and we started to see that space and time are not each absolute, and in fact, we can actually think of all events as happening in this continuum called space-time. And I say it fast, space-time. Because it's not saying space-time, two different things. It's saying that they're really just different directions in this continuum, space-time. And so, if they're all the same thing, why do we use different units for space and time? Why do we use seconds for time and meters for space, or at least in the examples that I've been doing so far? And so to fix that, instead of calling this the t prime axis or the t-axis, instead of labeling it in terms of seconds, what we can do, and this is the part that many of you will find disconcerting, let's call this the c times t prime axis. And let's call this the c times t axis. And the c times t prime axis. Well, what's that going to do? Well, we know that the speed of light is an absolute. It is, if we're measuring it in, and I'll do approximately because it's actually 2.9 something, but approximately 3 times 10 to the 8th meters per second. For the sake of all of these videos, I'm just assuming it's 3 times 10 to the 8th meters per second. For simplicity, it's roughly that. So if we were to take c times time, instead of this being 1 second in terms of seconds, well, we multiply it times 3 times 10 to the 8 meters per second. Well, the seconds cancel out, and we're left, this, if we want to measure time in terms of meters, would be 3 times 10 to the 8th meters. So this is 3 times 10 to the 8th meters, instead of calling it 1 second. This over here is negative. So that over there is negative 3 times 10 to the 8th meters along the c-t prime axis. Likewise, this, what we called 1 second right over here, instead, we can call this as 3 times 10 to the 8th meters. This, we could call negative 3 times 10 to the 8th meters. Now, this will be counterintuitive to you, because you've always viewed time as fundamentally something different than meters. You haven't been thinking in terms of space-time. And in fact, in our normal human experience, we don't experience the world in terms of space-time. Time is something that we're just falling forward into, and space is something that we feel like we have more agency and we can move in the different dimensions of space more easily, while time, it just feels like we're plummeting forward in that dimension. But now we're thinking in terms of space-time, and this makes our units the same. Now, if it helps you, you could view this as 3 times 10 to the 8 light meters. So you could think of it as the time it would take for light to go 3 times 10 to the 8th meters. Likewise, if we wanted everything in terms of what we traditionally conceive of as our time dimensions, we could have kept this as 1 second. Instead of calling this 3 times 10 to the 8th meters, we could have called this 1 light second, which would be the distance that light travels in what we measure or what we consider to be 1 second. But the benefit of this is now we're consistent. We're measuring different directions in space-time, which is kind of a continuum. There is no separate time and space. We're measuring them all in the same units, which we will find is very, very convenient. So I know this is going to take a little bit of time to get your head around, and I'll maybe do a few more videos to make you feel comfortable with this type of idea. But this will be a convenient thing for us, especially as we start to view, have a kind of a metric in our, what we would call our Minkowski spacetime, because we're going to be operating in the different dimensions as if they have the same units. So hopefully, I encourage you to kind of sit and ponder and think about this a little bit, and hopefully it doesn't bother you too much.